Given a billboard on a highway, and we're given the dimensions of said billboard, and there's a wind blowing on it. We're given the velocity of the wind and the density of air. We're also given a Reynolds number for the concrete base. We are given coefficients of drag for different areas, volumes. We're supposed to find the drag force on the billboard, the base, and how to reduce the drag. First, let's look at the drag force on the billboard. The drag force on the billboard is equal to the coefficient of drag times the density of air times the velocity of the wind squared times the area on which it's dragging. So this will be the billboard's face, because the wind's blowing normal to the face. And all this is divided by 2. So we look at our coefficients of drag, and the billboard most resembles the first one, because the other ones, well, don't look like billboards. So we're going to have the coefficient of drag be 1.3. Our density of air is 1.2 kilograms per meters cubed. Our velocity is given in kilometers per hour. So let's quickly figure out what it would be in meters per second, because that's just easier to do. Well, forgot it was on top. So that would be 41 2/3, so about 6-7. So take that and put it here. And then the area will just be, since we're taking the face, it's going to be 4 times 2 meters. So 8 meters squared. And then you divide that by 2. So force of drag equals 10,833 1/3, so approximately this. So that's the force of the drag on the billboard. Now let's find it on the base. Now we're given a Reynolds number for the base, and first we need to find if it's turbulent. Since it's 10 to the 6th, and it'll be turbulent if it's above 10 to the 5th, it's definitely turbulent. So we're going to use turbulent expression, which is 0.07. And to find the force of drag, similar to for the coefficient of drag, but this is the coefficient of friction. So this equals which pretty much is about 4.7, let's just say. Well, sorry, 0.0047. So this and that is not going to have any units because it's a coefficient. We have our density of air again, and our velocity of the wind. So and our area this time is going to be the base is surface, because we're going across the surface of the base. So it's going to be 16 meters squared, and all that divided by 2, which gives us 83 1/3, so approximately 83.3. So now, to reduce drag, we can reduce drag with at the base or at the billboard. If we look at the billboard, we can't change the density of air and we can't change the velocity of the wind. So we have to either change the coefficient of drag or the area. Changing the area is easy enough, just lower the area. Of course, if we're building this billboard on a highway, we probably don't want to reduce the area because more advertising space is better. Therefore, we're probably going to reduce the coefficient of drag. Now, obviously, this is the worst coefficient of drag compared to the other two. But if you think of the other two, the second one, you're going to also have the other surface, which will have a higher coefficient of drag when it's going that way. So really, the best billboard would be a cube, because while it's going to be higher than this billboard, it's going to be lower in coefficient of drag than this. However, that's pretty unreasonable given that, for making billboards, given that you're going to have to use much more material to make it. So we can also look at the base, and yet again we can't change the density of the air or the velocity of the wind. So we can change the coefficient of friction or the area. Now the best way to change the area would just be to either decrease the size, which would give you the problem that you don't have a big enough base, or to just put it underground. Because if we have our base underground, it won't be acting at all on it. Of course, for the coefficient of friction, well, they gave us the Reynolds number. The Reynolds number is really just referring to the concrete and the air going against each other. If we smoothed out the concrete or had a smoother substance than concrete, then we would also reduce drag. We can also reduce the drag by streamlining it. This would mean that we would take the billboard and make every part of it tangent to the wind's velocity vectors. However, this will pose a problem for the people designing the billboard because it will no longer be flat, and thus it will be probably harder to read. Also, if the wind is going in a different direction, say if the wind goes along this way instead of here, it will no longer be streamlined. Therefore, the best bet for the engineers of this billboard is to reduce the coefficient of drag for the base, the coefficient of friction for the base, or reduce the area by putting it into the ground for the base, or to just make either smaller billboards or cubic billboards, although that will again take the volume into account. So that is the coefficient of drag. Working with the coefficient of drag to find the drag force and reducing drag. Thank you.